Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will look at the transformations of square root functions. Now, our most basic square root function, sometimes called the parent function, looks like this. F of x is equal to the square root of x. Now, we can make a table of values for this function. But to make life easier for you when you're picking values of x, you want to pick values that are perfect squares so you can easily take the square root of them. For example, if I used 0, I can easily take the square root of 0. The square root of 0 is 0, and that's why we have a point on our coordinate plane at 0, 0. I can also easily take the square root of 1 because the square root of 1 is 1. So we have a point at 1, 1. I can easily take the square root of 4. That would give me 2. 1, 2, 3, 4, 1, 2. I can take the square root of 9. That's 3. That'd be here. I can even take the square root of 16, which is 4. That would go off our grid a little bit, but we could keep doing that process, getting as many values as you have room for, okay? So that's our basic square root function. What I want you to notice, though, is the domain is restricted. It is not all real numbers. The domain of the square root function starts at 0 and continues to infinity, which means the range is also 0 to infinity for the square root parent function. Now, we can move the square root function around on the coordinate plane if we change its parameters. So the transformation equation would look like this. F of x is equal to a times the square root of b parenthesis x minus c plus d. Now, this is very similar to functions we've transformed in previous lessons, but I want to remind you of a few things. The values of a and d, notice they are both outside of the square root symbol. The values of a and d, let me write this down, will only affect the y values. A and d affect the y values of the function, okay? Now, our coefficients that are on the inside of the square root symbol, the b and c, they will affect the x's. So b and c will only affect the x values. Only affect the x values. And that's going to be important in our examples to come. Now, a lot of this is going to feel like review to you because you've already experienced transforming quadratic functions and you've experienced transforming linear functions and absolute value functions. So a lot of this, once you get used to the square root function, is going to feel very familiar. Okay? Example 1. Describe how g of x and h of x are transformations of the graph f of x equals square root of x. Now in part A, we have g of x is equal to negative times the square root of x. Now notice where that negative is. It's on the outside of that square root symbol. So that means our a value in this problem is equal to -1. And we said at the top that a and d affect the y's. So what we're doing here is we're going to multiply, I'll just abbreviate that, each y value by -1. Okay, now our first ordered pair is 0, 0. If I multiply the y value, this value right here, by -1, 0 times anything is still 0, 0. So 0, 0 would transform also to 0, 0. So we're going to have a point right here. Now our next ordered pair is at 1, 1. So if I take 1, 1 and multiply that y value by -1, 1 times -1 would be -1. So our new y value would be 1, negative 1. All right. Now the third point we're going to transform from the original function is the point 4 comma 2. So if I took 4 comma 2 and I multiplied that y value by negative 1, I would get 4 negative 2. So that would be right here. Now notice how that changed that function. So our new function looks like this. Now, sometimes we say it opens down, but I want to describe this function. So when we have y equals negative times f of x, that's going to cause a reflection across the x-axis. A reflection across the x-axis. Now, let's look at our next problem here. Let me erase these original. Okay. I need to erase a couple more things. Let me get rid of that. It's 1, 1. And get rid of that highlighting. Okay. So in our next example, we have h of x equals the square root of negative x. Now, this time what I want you to notice is that the negative is under the square root. So that's going to affect our x values. So we're going, and that means b is negative 1. So we will multiply the x's by negative 1. All right, now let me grab a new color pen here. I'll use red. Okay, so 0, 0 would stay 0, 0. All right, that doesn't change, okay? Now, if I took 1 comma 1 and I multiplied the x value by negative 1, I would get negative 1, 1. So negative 1, 1, that would end up right here. And then if I took 4 comma 2 and multiplied the x by negative 1, that would give me negative 4 comma 2. Notice I didn't do anything to the y values. I just changed the x values. So 1, 2, 3, 4, 1, 2. So negative 4, 2 would land right there. So this function's going to go open to the left. Now let me summarize that. When we have y equals f of negative x, that's going to cause a reflection over the y-axis. That causes a reflection over the y-axis. All right, example 2. Describe how g of x and h of x are transformations of f of x equals square root of x. So in problem A, we have g of x equals the square root of x plus 2. Now notice this plus 2 is on the outside of our square root symbol. So that means the value of d is positive 2. And we will add 2 to our y's. We will add 2 to our y's. Now, let me put our critical points on here again, okay? So, again, if we had 0, 0, and I want to add 2 to my y values, my new y value would be 0, 2. Okay? Now, our second ordered pair critical point is 1, 1. And if I add 2 to the y value, I would get 1, comma 3. So do you see how that shifted up to? Then I'm going to take our third critical point, which was 4, comma 2, and I'm going to add 2 to the y value. So that would give me 4, comma 4. So what I want you to notice that each point on that original function shifted up 2 units, and it's going to look like this. So if we summarize, y equals f of x plus d, it will shift up d units. Okay. And now let me erase a couple things here. All right. In problem B, we have h of x equals square root of x minus 3. So in this problem, d is equal to negative 3. So we will subtract 3 from each y value. Subtract 3 from your y values. So if we have 0, 0, 0 minus 3 is 0, negative 3. Let me grab a different color here. I haven't used red yet. So 1, 2, 3. So we have a point here. Okay. 1, 1. 1 minus 3 is negative 2. So I have a point at 1, negative 2. And then 4, comma 2. 2 minus 3 would be negative 1. So 1, 2, 3, 4, negative 1. So notice that each point shifted down 3 units. So our verbal description here, y equals f of x minus 3, will shift the function down d units. All right, example 3. Describe how g of x and h of x are transformations of f of x equals the square root of x. In problem A, we have g of x is equal to the square root of x plus 2. Now, what I want you to notice is that this plus 2 is underneath the square root. And hopefully you remember that things with the x behave the opposite of how you think they are. So c in this problem will be equal to negative 2, which means we're going to subtract 2 from the x's. All right, so we have 0, 0. It's going to translate to something. Our second critical point is 1, 1, which will move to another point. And then our third critical point is 4, 2. We're going to, and let me just plot those there so you can see what's happening to the new points. All right, so that's our original function. Those are our 3 critical points we're going to use. Now, if I subtract 2 from the x's, that means 0, 0, I would get now negative 2 zeros. So my new function would start not at 0, but at negative 2. My second critical point is 1, 1. Well, 1 minus 2 would be negative 1, 1. So that would be right here. And then 4, 2. 4 minus 2 is 2, so that would be, I want to subtract 2. So that would be 2, comma 2. 2, 2. So right here. So what I want you to notice is that each point shifted to the left c units. So when we summarize this function transformation, y equals f of x plus c, we will shift to the left c units. Shift to the left c units. All right. Now let me erase those x values. All right. In our next problem, we have h of x equals x minus 3. So remember, if it's underneath the square root, it behaves the opposite. So c would equal positive 3. So we will add 3 to the x values. So 0, 0 becomes 3, 0. So 1, 2, 3. So now our function is starting at positive 3. 1, 1. 1 plus 3 is 4. Becomes 4, 1. So that would be right here. And then 4, 2 becomes 7, 2. 1, 2, 3, 4, 5, 6. It's going to go off the grid just a little bit, but I think you can get the general idea is that each point from the original function shifted to the right. So when we generalize that, y equals f of x minus c, our generalization will that it will be to shift to the right C units. All right, example 4. Describe how g of x and h of x are transformations of f of x equals the square root of x. In problem A, we have g of x equals 2 times the square root of x. So in this problem, the a value is 2. So we're going to multiply the y's by 2. So let's see, our critical points are 0, 0, 1, 1, and 4, 2. All right, if I multiply the y's by 2, 0, 0 will still be 0, 0. Okay, if I multiply 1, 1, if I multiply the y value by 2, I would get 1, comma 2. And here, 4, comma 2, if I multiply the y value by 2, I would get 4, comma 4. So that would be right here. So when we generalize this, y equals a times f of x, where the a value is bigger than 1. So in this case, it was 2. If it's a number bigger than 1, we call this a vertical stretch. Vertical stretch by a factor of BFO, by a factor of a, whatever a is. So in this problem, we stretched it by a factor of 2. All right, now let me erase these y values here for our next example. Right there. Let's see. Okay, so in problem B, we have h of x equals 1/2 times the square root of x. Notice the 1/2 is in front of the square root symbol, so that means a is 1/2. So we're going to multiply the y's by 1/2. So 0, 0 would still be 0, 0. Get a red. 1, 1, half of 1 is 1/2. So 1, 1/2. And 4, 2, half of 2 is 1. So this would be 4, 1. Now, to generalize this, if your a is a number that's between 0 and 1, like 1/2, our generalization is this is called a vertical compression by a factor of BFO a, by a factor of a units. So whenever your number is on the outside of the square root symbol, like this 2 or 1/2, it's always going to be a vertical stretch or a vertical compression. Okay, vertical stretch or vertical compression. All right, last one. Describe how g of x and h of x are transformations of f of x equals the square root of x. So in problem A, we have g of x equals the square root of 2x. Now, what I want you to notice now is that the 2 is no longer in front of the square root, it's inside, which means it's not going to behave how you think it should. So here, our b value is 2, but we don't multiply the x's by 2, we multiply them by the reciprocal. And the reciprocal of 2 is 1/2. So what that means for us, let me write, okay, I have my critical points, 0, 0. Well, if you multiply anything by 0, you're still going to get 0, 0. Okay, so my new point is still at 0, 0. All right. Our next critical point is 1, comma 1. If I multiply the x by 1/2, I'm going to get 1/2, comma 1. So go over half and up 1. That would be about right there. Our third critical point is 4, comma 2. And if I multiply the x by 1/2, I would get 2, comma 2. So 1, 2, 1, 2. So do you see that we vertically compressed excuse me, we horizontally compressed all of these x values. So instead of our critical points being here, here, and here, we've compressed them down. Okay, so excuse me. To summarize this, this is going to be when b, f of bx, if b is greater than 1, is a horizontal compression by a factor of BFO 1 over b. By a factor of 1 over b. So here's what I mean by it compressed. The 1 compressed to 1/2. The 4 compressed to 2. That's what's happening here. It's your x's. That's why it's horizontal. Okay? All right. Our next example, we have h of x equals the square root of 1/2 x. Again, notice that the 1/2 is under the square root. So it's going to do the opposite of what you think is going to happen. So it's going to multiply the x's by the reciprocal of 1/2. And the reciprocal of 1/2 is 2. So this time, 0, 0 will still say 0, 0. 1, 1. If I multiply 1 by 2, I would get 2, 1. And the 4, 2 would become 8, 2. So I'm multiplying all of the x values by 2. So let's plot these. We'd have 0, 0, 2, 1, and 8, 2. That's going to go off our grid a little bit, but it's going to look something like this. So here's what I want you to notice. The 1 became a 2. The 4 became an 8. So we are horizontally stretching by a factor of 1 over b. All right, example 6. Match each equation with the correct graph. So the goal here is not to graph these on your calculator and then match them up. The goal is to look at the equation and ask yourself, how is the graph shifting? So in the first one, f of x equals negative square root of x minus 2. What I know because of this negative is it's going to open down, okay? So I'm going to make myself a note. It's going to open down. And then what I know about this minus 2 is it's going to shift down two. Shift down 2. So hopefully you selected this graph. It opens down and it's been shifted down 2 units. So we'll put a letter E right here. All right. The next problem, f of x equals negative square root of x plus 2 plus 3. So here it's going to open down and it's going left 2 and up 3. So I want a graph that opens down and that moved left 2 and up 3. So hopefully you selected this graph here. Problem A. All right, next one. F of x equals square root of x plus 3 minus 2. So this graph is going to open up, and it's moving left 3, down 2. Left 3, down 2. So answer choice C. All right, problem F. F of x equals the square root of x minus 1. So the only thing that's happening here is this graph is moving to the right 1 unit. So problem D. All right. f of x equals 2 times the square root of negative x. Now I have a negative under the square root, so this graph is going to open to the left. There's only one graph on here that opens to the left. That would be answer choice F. All right, so our last one, 1/2 times the square root of x minus 1 plus 2. That is moving to the right 1 and up 2. And so the only one that matches that is letter B. All right, and that concludes today's lessons, transformations of square root functions.